Hello friends, welcome to lecture 6 from Digital Logic Design. Today's topic is binary addition. Binary addition means addition of binary numbers. Let us see single bit binary addition with the help of truth table. In the first truth table, let us take two numbers with a single bit each. The first number is AND, the second number we called it as AND. These two are inputs. Plus is the addition operator. The output is A plus B, which gives sum and carry. We have two inputs A and B. Now we should apply the binary for these two inputs. Then we should write the sum and carry in binary form. For two inputs, 2 power 2 combinations of binary we can apply. 2 power 2 equal to 4. That means 0, 1, 2 and 3. With the two inputs, 0 means its equivalent binary is 0, 0. 1 means 0, 1 based on the binary weights 2 power 0 and 2 power 1. 2 means 1, 0. 3 means 1, 1. Now we should apply addition operator between these two bits. Based on this, we should write the truth table 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1. 0 plus 0 means sum is 0, carry is 1. 0 plus 1 is sum is 1. 1 plus 0 is sum is 1, carry is 0. 1 plus 1 means its equivalent value is 2. 2 in binary form is 1, 0. Out of this 1, 0, 0 is the sum, 1 is carry. Okay. That's why sum we should write here, carry we should write here. Okay. So this is the truth table for single bit two numbers addition. Similarly, A plus B plus C, which gives the addition A plus B plus C and provides the outputs as sum and carry. Here three inputs we have taken. That's why 2 power 3 combinations we can write. That is 8. 8 means 0 to 7. The 0 equivalent binary with three inputs are 0, 0, 0. 1 means 0, 0, 1 based on the weights 2 power 0, 2 power 1, 2 power 2. We should write 2 as 0, 1, 0. 3 is 0, 1, 1. 7 is 1, 1, 1. Now we should apply plus operator between these bits. Okay. Based on this, we should write the truth table as 0 plus 0 plus 0, 0 plus 0 plus 1. Like this, we should write 1 plus 1 plus 1. Okay. Now we should write the sum and carry values. To write the sum and carry values, just add these bits. 0 plus 0 plus 0 is sum is 0. Here 0 plus 0 plus 1 is 1 with carry 0. Next 0 plus 1 plus 0 is 1 with carry 0. 0 plus 1 plus 1 is, here the sum is 2. 2 in binary form is 1, 0. This is a sum, 1 is a carry. That's why 0, 1. Again 1 plus 0 plus 0, this is 1, 0. 1 plus 0 plus 1. Here 2, 2 means same, 0 sum, 1 carry. 1 plus 1 plus 0, again 2. This is 0, 1. Here 1 plus 1 plus 1 is 3. 3 equivalent binary is 1, 1. This is sum, this is a carry bit. That's why we should write 1 and 1. Okay, in this way we should fill the truth table for single bit binary addition for two numbers and three numbers. Okay, in this way we should write the truth table for n number of inputs. But when we increase the number of inputs, it may take more time to write the sum and carry. To overcome that problem, so we should follow two tips. The first one is, if even ones are adding, the sum is 0, odd ones are adding, sum is 1. The second one is, the number of carries equal to number of pair of ones in addition. If we follow these two tips, then it is very easy to add any number of inputs to provide the outputs as sum and carry. Now let us check again these two truth tables. 0 plus 0 is sum 0 and carry 0. 0 plus 1 means odd number of 1, so that sum is 1. Here there is no pair. Pair means two ones, nothing but one pair. Okay. But here only single one, so that carry is 0. 1 plus 0 is again odd number of 1, so that output is 1. Sum is 1 and there is no pair of ones, so that carry is 0. 1 plus 1 is even number of ones, two ones. So sum is 0. Here 1, 1 is one pair. Okay. So that carry is 1. In this way, we should write for three inputs also. 0 plus 0 plus 0 is 0 with carry 0. Second one is 0 plus 0 plus 1. Here only single one, so that odd number of 1. Sum is 1, carry is 0. Next combination is 0 plus 1 plus 0. Again odd number of 1. Sum is 1, carry is 0. For the next combination, 0 plus 1 plus 1, even number of ones, sum is 0. Here one pair of ones is there, so that the carry is 1. Now 1 plus 0, odd number of 1, so that sum is 1. No pair of ones, therefore carry is 0. Here 1 plus 0 plus 1, even number of ones, sum is 0. 2 ones means one pair of ones, so that carry is 1. 1 plus 0, again even number of ones, therefore sum is 0. One pair of ones, therefore carry is 1. 1 plus 1, odd number of ones, 3 ones, therefore sum is 1, carry is 1 because these two are one pair. Okay. This way, we should write the binary addition for n number of inputs very easily with the help of these two tips. Clear? Now let us take one example. Addition of 6 numbers with 4 bits each. Here I have taken 6 numbers, number 1, 2, 3, 4, 5 and 6 with 4 bits each. To perform the binary addition for these numbers, now let us always start from LSB. Now we should add 1 plus 0 plus 1 plus 1 plus 1 plus 1. With the help of tips, it is easy to write the sum and carry. Now we should count how many ones are there. 1, 2, 3, 4, 5. Odd number of ones. So that sum is 1. 5 means 2 pairs of ones because these two one pair, these two another pair. So 2 carries are forwarded to the next position bits. Including carries, we should add all these bits. 1, 2, 3, 4, 5, 6. Even number of ones. So that the sum is 0. First pair, this is second pair, these two are another pair. So 3 pairs of ones are there, so that 3 carries are added. Now including these carries, we should add all these bits. Again count 1, 2, 3, 4, 5, 6. Even number of ones, so that sum is 0. 6 means again these two one pair, these two another pair, these two another pair. 3 pairs are there. So that 3 carries forwarded to the next position. Now including these carries 1, 2, 3, 4, 5, 6, 7. Odd number of ones, so sum is 1. Out of these 7, this is first pair, these two second pair, these two another pair. So 3 pair of ones. Here 3 carries are forwarded to the next position. Here there are no bits in the given numbers. So only we should add these carries 1 plus 1 plus 1. 3 ones are there, odd number of ones. So the sum is 1. Here out of these 3, this is only one pair. So 1 carry forwarded to the leftmost position. Now here there are no other bits, so that directly we should take the carry as a MSB. Now this is the final sum. 1, 1, 1, 0, 0, 1. Okay, 1, 1, 1, 1, 0, 0, 1. Okay, now we should check the answer. Here, when we convert these numbers in decimal form, the equivalent decimal value is 11 because 2 power 0, 2 power 1, 2 power 2, 2 power 3, these are the binary weights. So 8 plus 2 plus 1 is 11. In the same way, we should write the equivalent decimal numbers. Now we should add all these decimal numbers. Its equivalent value is 57. In the same way, we should convert the sum value into decimal. Then we should check. Here, this is 2 power 0, this is 2 power 1, this is 2 power 2, this is 2 power 3, 2 power 4 and 2 power 5. We should add the binary weights of corresponding ones only. 32 plus 16 plus 8 plus 1. Only we should add these binary weights. Its equivalent value is 57. This is the right answer. 7 binary numbers. Here I have given 7 binary numbers with 5 bits each. All of you try this addition. First you should try to solve this problem. Later you should check with my answer. I hope this topic is very helpful for you. If you like my video, please like, share and subscribe to my channel. Thank you.